Are primordial gravitational waves still coming to us? How big would a 30 billion solar mass black hole be? Do photons start experiencing time when they're slowed down in a medium? And in Q&A Plus, can any particle pop into existence anytime, anywhere? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Visto Tutti, since gravity travels at light speed, is that massive gravitational wave of the Big Bang still on its way to us? Yes. But it just passed us by. And now another one just passed us by. And then another one just passed us by. We just experienced the gravitational waves from the Big Bang over and over and over again. In the same way that we are always seeing the cosmic microwave background radiation. You know, when we look out into the cosmos and we are looking in microwaves, we are detecting this last scattering, this light that was released by the cosmic microwave background radiation into space. And that this was when the entire universe was like the surface of a red star. And then that light has been traveling through space. And right now, the light that has been traveling for 13.8 billion years just got to us. And then 1 second later, the next light that has been traveling for 13.8 billion plus 1 second has gotten to us. And then 2 seconds and so on, right? And so the same thing has happened with the gravitational waves from the Big Bang. Like there was a lot of mass moving around during the Big Bang. You know, we know this idea of inflation, where the universe expanded many orders of magnitude to a larger size. That was mass moving very quickly. And anytime you move mass, then that generates gravitational waves. And so there is this idea of primordial gravitational waves. And what's great about these is that they would be present in the universe earlier than the cosmic microwave background radiation. That is the earliest that we can see light, is 380,000 years after the Big Bang. Before that, the entire universe was like the surface or even the interior of a star. And so how do you observe the interior of a star? It is opaque. It's like being trapped inside the Earth and trying to observe the Earth. The Earth is opaque. It is rock, right? But the gravitational waves moved through the universe. And so right to the very, very beginning. And astronomers have been trying to figure out ways to be able to observe this primordial gravitational waves. One idea is that you would see the gravitational waves moving through the material that made up the cosmic microwave background radiation, and that it would change the light coming from the cosmic microwave background. Unfortunately, that hasn't panned out yet, but the next way is to use the pulsar timing array, which is the method where you have pulsars that are located all the way around in the sky. And they are sending us these signals with tremendous regularity, and astronomers can measure them as accurately as they measure an atomic clock. And so that we have already detected the background gravitational waves from merging supermassive black holes. So we know that these large background gravitational waves are there. There might be this second signal, the ones left over from the Big Bang. And if not, there have been proposals to build a gigantic version of LISA, which is the Large Interferometer Space Antenna, which is going to be directly detecting merging supermassive black holes. But if you build like a much bigger version, it's called the Big Bang Observer. It would have 12 LISAs in this giant sort of grid, and they would be able to potentially detect the gravitational waves coming from the Big Bang itself. And another gravitational wave just went past us, right? Like we are always, every second that goes by, we are experiencing another second's worth of the gravitational waves from the Big Bang. It's just that they are extremely faint, that they are incredibly difficult to detect, that a car driving around on a road is shaking your detectors more than the gravitational waves that you would be able to detect. So it's just going to take new technology and new investment, but it is theoretically within our ability. Arias, third of his name. Fraser, what do you know about charged black holes? I thought black holes only had mass and spin, but yesterday I saw a video from David Kipping where he mentioned charged black holes. Yeah, so black holes can be measured by three numbers: the mass, the spin, and the charge. And these are made up of essentially the raw material that went into the black hole. So, the mass one is relatively straightforward. All of the gas and dust and light and antimatter and planets and you name it had mass, or had the mass equivalent from the energy. E equals mc squared, right? And that added to the mass of the black hole. And then so that number, that total mass, becomes the mass of the black hole. Same thing with the spin. All of that material as it's going into the black hole had some kind of spin associated with it before it went into the black hole. And the black hole preserves that spin and spins. So whatever direction the black hole is spinning and whatever speed the black hole is spinning, this is the sum of all of the material that has fallen into the black hole. And then generally they end up spinning at relativistic speeds, close to the speed of light, which is crazy. But the last number is the charge. And so every particle that goes into the black hole will have had a charge. And then the black hole is going to be the average charge of all of that material that fell into it. The thing is that charged material generally balances out. So you have positives, you have negatives. And so generally a black hole is going to be roughly neutrally charged. But theoretically, it could be, if you only fed a black hole on positively charged material, then the black hole would gain a positive charge. And the crazy part is that then if you had, say, something that was negatively charged, then you would attract it in addition to the gravitational, right? And if it had something that was also positively charged, it would be repelled by the black hole. So so black holes can have their mass, their spin, and their charge. It's time to shout out the new $5 patrons and above: Jimmy Jong, Graham Jenkins, Danielle Perkins, Bob Cook, Jesper Peterson, Shane Larkin, Felix the Cat, David Burden, Rev Keith Carter, and Ian Menick. Join the club at patreon.com/universetoday. Known unknown, how large compared to the solar system is a 30 billion solar mass black hole? So I'm not exactly sure what a 30 billion solar mass black hole would be, but the most massive black hole that we know of is called Phoenix A, which is a supermassive black hole in the Phoenix cluster. And it probably has somewhere on the order of 100 billion times the mass of the sun. And so here's the part that's crazy. The event horizon of a black hole that big is 3,900 astronomical units, or 0.06 light years. So 6% of a light year. When you think about the distance from the sun to Pluto, it's about 50 astronomical units. So you can sort of do the math. It's like less than 100 times the distance from the sun to Pluto. So it's big. It's very big, but it is not very big compared to, like, you could hold it within the entire solar system. The Milky Way has about 1.5 trillion solar masses in it, and the Phoenix A black hole has 100 billion. So it's maybe less than 10% the mass of the entire Milky Way, but it's still a very big black hole. Hangman 747 Tin Man. Due to light speed, a photon experiences no time. Does a photon experience time when it's slowed down in a medium? No, but it is an interesting idea, right? That photons experience no time. That if you sort of calculate the time dilation, you put in the speed of light into it, things cancel out, and the amount of time that is experienced is zero. And so for a photon that's traveling at the speed of light, and so the photon never experiences time. It always feels like it is moving at the speed of light. But there's an interview that's coming out, and the reason I sort of want to talk about this question is that when light passes through like a medium or like gas, dust, things like that, then you can actually get wavelengths arriving a little bit slower. You know that light travels at a different speed through water, and that you can actually then measure what the universe is made of by how that light arrives at different times to your eyes. That different wavelengths are sort of split apart by different stuff in between. It's a crazy idea, but there's an interview coming out. You gotta hear about this. Old timer. Andromeda is predicted to collide with the Milky Way, but is it traveling towards us? Are we traveling towards it, or both? Yeah, it's both. We are attracted to Andromeda, and Andromeda is attracted to us. It's a mutual attraction. And so now Andromeda is the more massive galaxy. So it has roughly, they think it might be about 3 times as massive as the Milky Way. And so it is doing the majority of the gravitational attraction, but the two galaxies are are essentially moving towards a common center of gravity between the two of them. Now, there is still an argument whether or not Andromeda and the Milky Way will actually merge, that it might just be that it's a close flyby, and then the three-body interactions between Andromeda and the Milky Way and the Triangulum galaxy will cause them to not actually merge in the end, but still. So we are moving towards Andromeda. Andromeda is moving towards us. And that's why when we look at the light from Andromeda, it is blue shifted. While almost every galaxy that we see in the entire universe is red shifted, that the galaxy is moving away from us, Andromeda is one of the few that is actually moving towards us. Epic Quest Bio. Has anyone considered using railguns to launch ultra-high aspect ablation-shielded microgram payloads to escape velocity from their backyard? So people have been working on ideas for using railguns to launch payloads into space. The problem is, and this is like people have proposed using railguns for ship-mounted weapons as well, because wouldn't it be great? You just take a ton of electricity, you accelerate the railgun, you send projectiles just using electricity. You don't need to carry gunpowder on your ship. You just need to be able, as long as you can generate electricity, you can be firing off projectiles. The problem is that it causes enormous strain on the railgun itself. And there's a sort of a joke in the military community, which is, show me a railgun that can fire twice. So the railgun can fire once, but then it has mangled itself. And if it tries to fire a second time, it is no longer functional. And so the amount of engineering that needs to go in to be able to make a railgun actually work at the kinds of velocities that are comparable to what a shell can do is still science fiction. But people have proposed various ideas on how you could try to use railguns to accelerate payloads into orbit. The problem is that there's a bunch of problems. So the first problem is that you are hitting the thickest part of the atmosphere the moment you let go of your payload, that you are at the bottom of this ocean of air, of atmosphere. And then you have to be able to send this thing up through that. And at the kinds of speeds that you want to go to be able to have enough momentum to be able to get up into orbit, you are going to explode your projectile. So that is challenge number one, because you got to go 28,000 kilometers per hour. You get to go really fast. Or what's escape velocity? Or orbital velocity, I think it's like 7.66 kilometers per second. Like, it's really fast. So that's your first problem. And then, of course, there's the problem of you tearing apart your railgun. And then, of course, there's the problem that if you're going to try to get that kind of acceleration, you are going to have to exert tens of thousands of Gs of force on your payload. And you need very special payloads that can handle those kinds of forces. It's not outside of the realm of possibility, but it still is very, very difficult. And so, all attempts so far to build railguns of any size, I don't know about anyone's using ablation-shielded microgram payloads, but they still run into the same problems, which is you better have a really good ablation, because you're going to hit the brick wall of the atmosphere the moment you get out of the vacuum where you were accelerating your payloads, and then it's going to ablate completely to death. Did you know you can watch the same video with no ads and get a bonus question over on Patreon, completely for free? We call it Q&A+. And this week's bonus question: can any particle pop into existence anytime, anywhere? And I'll put a link down in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who asked your questions into the YouTube comments, everybody who joined me for the live show. I'm going to talk about a couple of YouTube channels that I like and just what seems to be happening on YouTube in general. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Brian Bodie, Carradine, Chuck Hawkins, Commander Baylock, Dirk Finga, David Gilton, and David Matz, and Thralla Reading and Math for Toddlers, Evan.Pro, James Clark, Jeremy Mattern, Jim Burke, Marcel Simmons, Michael Purcell, NASA Ocean Guy, Nordspace, OneStepForAnimals.org. Please follow my nephew at VBrick6994, Renkaidu, Richard Williams, Sean Sargent, Stephen Finley, Team 49, Telescopes Canada, Vlad Jeplin, Wolfgang Klotz, Zelda, sorry, the loose blue-booted moose looped around 9 narrow lunar lava tubes, about time, eh? Who support us at the Master of the Universe level, and all our patrons. All your support means the universe to us. So I was watching a couple of my favorite YouTube channels this week, and there was an interesting similar theme that came out of both of them. And so first I want to share the channels because I think they're great. First up, I want to share Weird Explorer. And this is a channel from Jared Ryderlich, and he travels the world finding and trying to get his hands on every single fruit in existence. And I think he's mostly wrapped it up. Every berry, every fruit, apple, everything you can imagine, he has tried these fruits, and fruits you've never heard of. And I am a big forager. I love to go into the forest to find, we have lots of berries and fruit that you can eat here on Vancouver Island. And I love trying, whenever I go to a new place, I try and find all of the fruit that I can get my hands on and try it all. And clearly we're of the same mind, and it's a great channel. And then the next channel that I want to share with you is Film Joy, and this is Movies with Mikey. And he is a film reviewer, but his reviews are just unique, like nothing else you've ever seen, and has a very interesting perspective on things, has a sort of a stylistic language in the way that he shares his reviews of movies. And even if you've seen the movie, you get a lot more out of it by watching his reviews. And he talks about new stuff, and he also goes back and talks about older stuff as well. And it's hard for me to explain how kind of cozy and entertaining the Movies with Mikey are, but if you know, you know. And so you should definitely check out that channel. And the reason I bring up both of these is because I was watching both of their new videos this week, and both of them said, I don't know why, but I seem to have dropped off the YouTube algorithm. And that sucks, because they're both really great channels and are putting out a lot of really great content. And yet you just fall out of favor from the YouTube algorithm, to the point that Mikey is looking for work. Right? Like, he is such a good movie reviewer that he shouldn't have to be looking for work, and yet he is. That sucks. So definitely check out his new video, and if you have a job for him, I guess. But, we as creators exist at the whim of the YouTube algorithm. And you as the viewers, you don't realize that you are just being pushed and pulled in whatever direction the YouTube algorithm wants you to go, thinks you're going to like. And I find that a lot of the time it wants to push you towards mainstream media and kind of celebrity culture. And I have to resist it in my own algorithm. And the trick is that you go to your subscriptions page, and then that will only be the videos from the people that you have subscribed to, and then use that as your main homepage to go to YouTube. Like, don't just go to YouTube, go to your subscriptions page. And then that will make sure that you're able to watch the videos from the creators that you like. And if you aren't enjoying those creators anymore, then unsubscribe from them. And then that way you won't see them in that mix, but you'll get this kind of pure experience watching the video creators that you like. So Weird Fruit Explorer, Movies with Mikey, and go to your subscriptions tab. All right, we'll see you next time.